Hello, and welcome to tonight's Space Sleep Story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight we embark on a journey to observe the wandering stars, the 5 classical planets visible to the naked eye from Earth: Mercury, Venus, Mars, Jupiter, and Saturn have captivated humanity since before recorded history, moving against the background of fixed stars. So, settle into your most comfortable position, close your eyes, and prepare to explore our cosmic neighborhood through peaceful observation. Before we begin, let us prepare your body and mind with gentle breathing. Take a slow, deep breath with me now. Inhale gently for 4 counts. Hold the peace. Exhale for 6. Feel your body releasing into stillness. Notice how your shoulders drop, your jaw relaxes, your entire being settles into this moment. Each breath brings you deeper into rest. Another gentle breath as we continue our preparation. This time, notice how your chest rises and falls, how air flows smoothly in and out. Let my voice be your guide. Hold this peaceful moment. Feel the stress of the day leaving your body. With each breath, you release a little more into relaxation. Your mind quiets, your thoughts slow. You are safe and comfortable here. Tonight we observe differently than we might observe distant stars. While those suns remain fixed in their patterns over human lifetimes, 5 special lights wander against that stellar background. The planets, from Greek planetes meaning wanderers. These aren't distant suns light years away. They're neighbors within our solar system, worlds orbiting the same sun, close enough that their motion becomes visible within days or weeks. Ancient observers watch them puzzle across the heavens. Let us begin identifying the 5 classical planets visible to naked eye. Venus, when present, is unmistakable. Magnitude -4.89, brighter than anything except sun and moon. It appears as brilliant evening star after sunset or morning star before dawn. Never visible at midnight, always near the sun in our sky, Venus follows its 225-day orbit inside Earth's path. When you see Venus blazing in twilight, you're seeing reflected sunlight from a world 41 to 258 million kilometers away. Jupiter, the second brightest planet, shines with steady, unwavering light. Magnitude -2.94 at opposition, when Earth passes between Jupiter and the Sun. Visible most of the year except when near conjunction with Sun. Its steady glow distinguishes it from twinkling stars. Through binoculars, you might glimpse 4 points near Jupiter, the Galilean moons Galileo discovered in 1610. When observing Jupiter tonight, You're receiving photons that left its cloud tops 33 to 52 minutes ago. Mars glows with distinctive orange-red color, iron oxide covering its surface. Rust visible across tens of millions of kilometers. Its magnitude varies dramatically, from negative 2.94 at close opposition to positive 1.86 at conjunction. Every 26 months, Earth overtakes Mars in our faster inner orbit, bringing them closest together. Mars brightens and dims through this cycle, sometimes rivaling Jupiter in brilliance, other times fading to modest, star-like point. This variability puzzled ancient astronomers. Saturn glows golden yellow, magnitude 0.49 to 1.47. Its steady light requires dark adaptation to appreciate fully. Orbital period, 29.46 years, slowly traversing the zodiac constellations. Through small telescopes, Saturn's rings become visible, but to naked eye, it appears as golden point of light. Ancient observers noticed Saturn occasionally appeared round, occasionally oval, in predictable cycles. The rings changing orientation as Saturn orbits explain this mystery. Mercury, the most elusive classical planet, never strays more than 28 degrees from the Sun. Magnitude ranges from negative 2.48 when bright to positive 7.25 when invisible. Visible only during twilight as morning star or evening star for a few weeks at a time. Always near the horizon, often lost in solar glare. Observing Mercury requires knowing exactly when and where to look, patience, and clear skies. Ancient astronomers treasured Mercury sightings. How do we distinguish planets from stars? The most reliable method involves observing their light. Stars twinkle, their light scintillating as it passes through Earth's turbulent atmosphere. Planets show steady, unwavering glow. Their closer proximity and larger apparent disks average out atmospheric distortion. When you see a bright, steady light in the night sky, not flickering like surrounding stars, you're likely observing a planet. This steadiness, visible to naked eye, helped ancient observers identify wandering lights. Planetary colors provide additional identification clues. Mercury appears gray-white, neutral. Venus brilliant white from cloud reflection. Mars distinct orange-red from iron oxide. Jupiter cream white with subtle atmospheric bands visible through telescopes. Saturn golden yellow. These colors visible to naked eye helped ancient cultures distinguish planets from each other and from stars. Color combined with brightness, position along the ecliptic, and steady glow makes identification possible even from light-polluted cities. For millennia, these 5 wandering lights puzzled observers. Why did they move against the fixed stellar background? Babylonians documented Venus positions on clay tablets 3,600 years ago, tracking its 584-day cycle. Greeks named planets for gods based on characteristics: swift Mercury, beautiful Venus, warlike Mars, mighty Jupiter, ancient Saturn. Romans applied equivalent deity names still used today. These observers had no telescopes, no understanding of solar system structure, yet recognized planets' special nature. Ptolemy's model from 150 CE attempted explaining planetary retrograde motion. Complex epicycles, small circles upon larger circles orbiting Earth. The model predicted positions accurately, but required increasingly complex adjustments. For 1400 years, this geocentric system dominated astronomy. Planets moving backward, forward, looping across the sky, defied simple explanation. The mathematics grew elaborate, patch upon patch, attempting to save appearances while maintaining Earth at universe center. Truth awaited better observations. Nicholas Copernicus in 1543 proposed revolutionary solution. Place the sun at center. Planets orbiting in order: Mercury, Venus, Earth, Mars, Jupiter, Saturn. Retrograde motion explained naturally as perspective effect. When Earth overtakes outer planet in our faster inner orbit, that planet appears to move backward against stellar background, like passing car on highway appearing to move backward relative to distant mountains. Suddenly the complex epicycles vanished, replaced by elegant geometric simplicity. Heliocentrism revealed truth. Understanding what causes planets to wander requires grasping orbital mechanics. Mercury and Venus orbit inside Earth's orbit, called inferior planets. They never appear opposite Sun in sky. Maximum angular separation, called greatest elongation. Mercury reaches 18 to 28 degrees. Venus reaches 45 to 47 degrees. Best observing opportunities occur at greatest elongation, when planet highest above horizon during twilight. They're always morning or evening objects, never visible at midnight. Geometry constrains their appearances. Mars, Jupiter, and Saturn orbit outside Earth's orbit, called superior planets. They can appear opposite Sun at opposition when Earth passes between them and Sun. Planet visible all night, rising at sunset, setting at sunrise, at closest approach to Earth, brightest and largest apparent size. At conjunction, planet appears near Sun, invisible due to solar glare. Superior planets traverse full circuit around our sky over months or years, unlike inferior planets bound to solar vicinity. The synodic period determines how often planet returns to optimal viewing position. Time between successive oppositions or conjunctions. Mars, synodic period 780 days, 26 months. Jupiter, 399 days, 13 months. Saturn, 378 days, 12.5 months. These cycles reflect interplay between Earth's orbital motion and each planet's motion. Ancient astronomers documented these patterns, predicting planetary positions accurately, even without understanding underlying physics. Pattern recognition preceded comprehension. Consider the distances involved in planetary observation. Venus approaches within 0.28 astronomical units at inferior conjunction, 41 million kilometers, closest planet to Earth. Mars reaches 0.37 AU at closest opposition, 55 million kilometers. Jupiter at opposition sits 3.93 AU away, 588 million kilometers. Saturn at opposition, 7.99 AU, 1.2 billion kilometers. Light from Saturn takes over an hour to reach your eyes. You observe the past. When Galileo turned his primitive telescope skyward in 1610, planetary astronomy transformed. January 7th, he observed 3 small bright stars near Jupiter. January 8th, different positions. By January 13th, a 4th appeared. Within 1 week, undeniable conclusion. 4 objects orbiting Jupiter, not Earth. He had discovered moons, satellites, something never before imagined. Not everything orbits our world. The geocentric certainty shattered against telescopic observation. Truth revealed through patient watching. Between December 1610 and January 1611, Galileo documented Venus showing complete phase cycle. When Venus near Sun at inferior conjunction appeared large and crescent, when far from Sun at superior conjunction appeared small and gibbous. This behavior proved Venus orbits Sun, not Earth. Ptolemaic geocentric model would show only crescent phases. The phases visible through telescope matched Copernican prediction perfectly. Observational evidence compelling. Heaven's structure revealed through magnified light. After Galileo's revelations, astronomers sought deeper understanding. Why do planets occasionally move backward against the stars? This retrograde motion puzzled observers for millennia, driving complex theories attempting to explain the strange loops planets trace. The answer lies in perspective. When Earth, orbiting Sun at 30 kilometers per second, overtakes Mars moving at 24 kilometers per second, Mars appears to reverse direction against background stars. Not because Mars stops, but because our viewpoint changes. Like passing a slower car on the highway, the distant mountains seem to move backward relative to the car you're passing, though mountains remain stationary. Retrograde motion is geometric inevitability of heliocentric arrangement. Johannes Kepler inherited Tycho Brahe's Mars observations. 20 years of nightly measurements, precise to 1 arc minute. 1/60th of a degree, 1/3000th of a complete circle. Extraordinary precision without telescopes. Kepler spent 5 years analyzing Mars data. The orbit wasn't circular as everyone believed. The difference between computed and observed position, only 8 arc minutes. From this tiny discrepancy, he rebuilt astronomy. Kepler's first law. Planets orbit in ellipses, not circles, with the sun at one focus. His second law. Planets sweep equal areas in equal times, moving faster when near sun, slower when distant. His third law, published 1619, a planet's orbital period squared is proportional to its distance from sun cubed. Mathematical relationship governing all planetary motion. Transformed astronomy from geometry to physical science. These laws revealed order in apparent chaos, retrograde loops, brightness changes, timing variations, all explained by elliptical orbits and varying speeds. The solar system operates according to mathematical principles, predictable, knowable. Now let's deepen our understanding of each planet. Mercury, innermost world, orbits Sun every 88 days, never strays more than 28 degrees from solar glare. Difficult to observe, visible only during twilight. Mercury's surface endures temperature extremes. -173 Celsius during night, +427 Celsius during day. No significant atmosphere to moderate temperatures. Heavily cratered like our moon. Its rotation is locked in 3:2 resonance with orbit. 3 rotations for every 2 orbits around Sun. Unusual gravitational relationship creating long days. Strange solar motion in Mercury's sky. Venus shines brilliantly because thick sulfuric acid clouds reflect 70% of sunlight. Closer examination reveals hellish world. Surface temperature 462 Celsius, hot enough to melt lead. Venus's atmosphere creates crushing pressure. 92 bars at surface, 93 times Earth's atmospheric pressure. The weight would crush unprotected human instantly. Runaway greenhouse effect transformed Venus from Earth-like world to inferno. Yet Venus remains beautiful from distance. That brilliant point of light holds secrets about planetary evolution. How atmospheres can transform worlds. Venus is Earth's cautionary tale written in clouds and heat. Mars glows distinctly red from iron oxide covering its surface. Rust visible across tens of millions of kilometers. The planet appears different from season to season, growing bright at opposition, fading at conjunction. Mars's brightness varies dramatically, from magnitude -2.94 at close opposition to positive 1.86 at distant conjunction, 7-fold brightness change as Earth and Mars dance their orbital ballet. This variation fascinated ancient observers. Mars sometimes dominated the night sky, rivaling Jupiter. Months later, it faded to ordinary reddish star. The 26-month opposition cycle became predictable calendar for watching Mars. Spacecraft revealed Mars's ancient past. Valley networks carved by flowing water 3.5 billion years ago. Lake beds were liquid-filled basins. Polar ice caps containing frozen water. Evidence Mars once was warmer, wetter. Jupiter dominates when visible. Magnitude -2.94 at opposition, second only to Venus in planetary brightness. That steady cream-white light comes from world 11 times Earth's diameter, 800 million kilometers away. Jupiter rotates faster than any planet. 9.93 hours for complete rotation. Day less than 10 hours despite its enormous size. This rapid spin creates powerful winds, turbulent atmosphere, visible through telescopes. Jupiter's Great Red Spot is storm larger than Earth, persisting for more than 300 years. Winds reach 430 kilometers per hour. This anticyclonic tempest has raged since before telescopes revealed its existence. Ancient weather system. Galileo's telescope revealed 4 bright moons orbiting Jupiter. January 1610, he watched these points of light changing positions nightly. Io, Europa, Ganymede, Callisto. Proof that not everything orbits Earth. Revolutionary discovery made with primitive optics. Today, you can see Jupiter's Galilean moons through binoculars. 4 points near the bright planet, rearranging themselves each night as they orbit. The same sight that changed astronomy 414 years ago. Accessible wonder. Jupiter's mass exceeds all other planets combined. 318 times Earth's mass, 2.5 times every other planet added together. Jupiter nearly became star, but lacked sufficient mass to ignite fusion. Its magnetic field is enormous, 20,000 times stronger than Earth's. Radiation belts trap charged particles, creating deadly zones. Pioneer and Voyager spacecraft endured intense radiation passing Jupiter. Instruments stressed by electromagnetic assault. Jupiter primarily consists of hydrogen and helium. No solid surface exists. Atmosphere gradually transitions to liquid metallic hydrogen deep within. Pressures and temperatures beyond terrestrial experience. Alien world through and through. Saturn glows golden yellow. Magnitude ranging from 0.49 to 1.47. Depending on distance and ring tilt. Less bright than Jupiter or Mars at opposition, yet unmistakable once identified. Saturn's rings make it most visually spectacular planet. Extending 282,000 kilometers in diameter, but only 10 meters thick, incredibly flat disk of ice particles, ranging from dust grains to house-sized chunks. Ancient observers noticed Saturn appeared oval. Their eyes couldn't resolve rings, but subtle elongation suggested something unusual. Saturn occasionally appeared round, sometimes with handles or ears. This variation followed predictable 29-year cycle. Galileo first observed Saturn 1610. His primitive telescope revealed confusing appearance. The planet seemed to have handles or ears extending from sides. 2 years later, the handles vanished. Galileo was bewildered. "45 years later, Christian Huygens solved the mystery. Using improved telescope, he recognized thin, flat ring surrounding Saturn. Published 1655. It is surrounded by ring, nowhere touching, inclined to ecliptic." Revolutionary observation. Ring appearance changes with Saturn's seasons. Saturn's axis tilts 27 degrees. When ring plane faces Earth, rings appear wide open, spectacular. When edge on, they vanish, too thin to see. Giovanni Cassini discovered gap in Saturn's rings. 1675, he identified division 4,800 kilometers wide. Cassini division separates outer A ring from inner B ring, visible through small amateur telescopes today. Cassini also measured Jupiter's rotation period accurately, 9 hours 56 minutes, close to modern value of 9 hours 55 minutes. He directed Paris Observatory for 40 years, advancing planetary astronomy significantly. Saturn's day length, 10.66 hours, nearly as fast as Jupiter, despite slightly smaller size. This rapid rotation flattens Saturn noticeably. Equatorial diameter exceeds polar diameter by 10%. Visibly oblate world. Saturn's composition resembles Jupiter, primarily hydrogen and helium, no solid surface. Atmosphere exhibits bands and zones, though less dramatic than Jupiter's. Occasional storms erupt, great white spots visible from Earth. Saturn orbits Sun every 29.46 years, nearly 30 Earth years for a single Saturnian year. If you're 30 years old, Saturn has completed roughly one orbit since your birth. Slow, stately progression. Saturn reaches opposition every 378 days, 12.5 months, slightly over one Earth year. Each opposition, Saturn appears in next zodiac constellation, gradually moving through sky. Light from Saturn takes 68 to 85 minutes reaching Earth. When you observe Saturn tonight, you see it as it appeared over an hour ago. Photons traveled 1.2 billion kilometers, crossing solar system to enter your eye. Space-age exploration transformed our understanding. Pioneer 11 first visited Saturn, 1979. Voyager 1 and 2 followed, revealing intricate ring structure, discovering new moons. Cassini mission orbited Saturn 13 years, 2004 to 2017. Between 1960s and today, spacecraft transformed planets from telescopic abstractions into known worlds. Venus revealed its crushing 462-degree surface. Mars showed ancient river valleys. Each mission answered questions, yet each discovery raised new mysteries. The more we learned, the more we understood how much remains unknown. Heidi Hammel studied Jupiter and Saturn through Hubble for decades, yet she still goes outside to observe them with her eyes. The same photons Galileo saw. Light leaving Jupiter tonight travels 45 minutes across 800 million kilometers. That photon journey connects you intimately to that distant world, across vast space. Babylonian astronomers 3,600 years ago watched these same planets. They tracked Venus on clay tablets, they recording its 584-day cycle with careful precision. The Venus tablet of Ammisaduqa documents 21 years of observations. Specific dates when Venus appeared as morning star, disappeared, then reappeared as evening star. These ancient scribes couldn't know Venus orbits the Sun. They couldn't explain the pattern, but they recorded it faithfully, generation after generation. Greek astronomers named planets for gods based on their characteristics. Swift Mercury, beautiful Venus, warlike Mars, mighty Jupiter, ancient Saturn, Ptolemy in 150 CE attempted explaining retrograde motion. He proposed epicycles, small circles upon larger circles, orbiting Earth, complex mathematics predicting positions. The Ptolemaic model grew increasingly complicated as observations improved. Yet it dominated astronomy for 1400 years, until Copernicus proposed something simpler. Islamic astronomers between 800 and 1200 CE refined planetary measurements. Al-Battani calculated orbital parameters, accurate to within minutes of arc. Extraordinary precision. Arab scholars preserved Greek astronomical knowledge through Europe's Dark Ages. They questioned epicycles' physical reality. They expanded understanding. They passed knowledge forward. Tycho Brahe observed Mars for 20 years from his island observatory. Night after night, year after year, achieving 1 arc-minute precision without telescopes. Tycho didn't know why such precision mattered. He simply measured positions as accurately as humanly possible. His dedication would transform astronomy after his death. Johannes Kepler inherited Tycho's Mars data in 1601. He spent 5 years analyzing those observations, wrestling with an 8 arc-minute discrepancy. Kepler wrote that 8 arc-minutes was no greater than Tycho's measurement error. But if Tycho could measure that precisely, Kepler couldn't ignore the difference. From those 8 arc-minutes, Kepler rebuilt astronomy. The orbit wasn't a circle, it was an ellipse. Planets sweep equal areas in equal times. "25 years combined, 20 years for Tycho's observations, 5 years for Kepler's analysis. Patience revealing truth about planetary motion." Galileo turned his telescope toward Jupiter on January 7, 1610. He noticed 3 small bright stars near the planet. The next night, their positions had changed. By January 13th, Galileo had observed a 4th companion. They realized these were not stars. They were moons, worlds orbiting Jupiter. Clipping number. John Dobson invented the simple telescope that bears his name. He showed thousands of people Saturn for the first time. Grown adults gasped when those rings came into focus. He would tell them afterward, "You can see Saturn with your naked eye tonight. That yellow-white star." They looked amazed. "I've been seeing that my whole life." Carolyn Shoemaker hunted comets and asteroids for decades. At first, planets were obstacles, bright objects obscuring faint ones she sought. Eventually, they became familiar friends. She learned planetary positions by heart. Jupiter here, Saturn there, Mars moving through this region. The wandering stars lived up to their name. Faithful companions. Stephen James O'Meara spent decades chasing Mercury, the innermost planet, never far from Sun, always lost in twilight glow near horizon, the hardest classical planet to observe. Easter Island, March 1997. Mercury magnitude -1.9, crystal clear. Visibly showing phase through small telescope. After years of attempts, finally seeing the innermost world. Neil deGrasse Tyson speaks of pointing out planets to children. Their minds expand. That's not just a bright star, That's Jupiter with 79 moons. That one is Saturn with rings. Suddenly, the sky isn't decoration. It's a neighborhood. We live in a solar system, not on an isolated Earth. A neighborhood of worlds. Heidi Hammel studied Jupiter and Saturn through Hubble for decades, observing storms, tracking clouds, measuring wind speeds. But she still goes outside and looks with her eyes. There's something profound about seeing Jupiter with the same photons Galileo saw in 1610. The light hitting my setter traveled 800 million kilometers. Intimate connection across space. Carolyn Porco led Cassini's imaging team for 13 years at Saturn. 20 years of planning, 13 years in orbit. But she still remembers first seeing Saturn through telescope at age 10. That tiny golden oval with tiny rings sparked everything. Her career, her passion, her life's work. The child seeing Saturn became scientist commanding spacecraft there. Timothy Ferris taught planetary identification for years. He called it the easiest entry to astronomy, Brightest object in evening sky? Venus. That steady reddish one? Mars. Unlike constellations requiring dark skies and memorization, planets announce themselves. They're visible from cities. Once you know them, you track them for life. Old friends. Alan Hale observed the sky systematically for decades. During those years, planets were constants. Jupiter visible 11 months a year, Saturn 11 and a half months, Mars on its 26-month cycle. This long-term familiarity taught patience. The solar system operates on timescales longer than human attention spans. Slow observation reveals patterns. The Venus that Babylonian scribes documented 3,600 years ago is the same Venus shining tonight. Same orbit, same brightness. Mars that puzzled Ptolemy with retrograde motion. Is Mars you see overhead, same orbital mechanics, same perspective effect. Jupiter's moons that amazed Galileo in January 1610 orbit tonight, visible through binoculars, just as they were then. We observe the same solar system, continuing millennia-long human tradition, ancient patterns persisting. Wandering stars wander on, clipping number. The planets continue their ancient orbits. Venus swings around Sun. Jupiter's clouds swirl endlessly. All moves as it should. Mars glows red tonight. Saturn's rings catch sunlight. Mercury hides near horizon, each world following its path. These companions have watched over Earth for billions of years. Long before humans looked up, they will continue long after. Your breath matches orbital rhythms, slow, endless, circular patterns repeating through time, peaceful motion. Tomorrow night the planets will have moved slightly. Jupiter's moons rearranged. Venus closer or farther. Patterns persisting. The same light Galileo saw in 1610. The same Venus Babylonians documented. You observe ancient continuity. No need to track every position tonight. The planets know their paths. Orbital mechanics continue. You rest. Light from Jupiter began its journey 45 minutes ago. From Saturn over an hour. Ancient photons reaching you now. The wandering stars wander on. Mercury completes another orbit. Mars continues its path. All proceeds without concern. These 5 companions, visible tonight: Venus, Jupiter, Mars, Saturn, Mercury, neighbors in the solar system, watching. Planets keep watch. You rest now. Planets, you learn this way. You rest now. Planets, you learn this way. You rest now. Orbits continue. Peaceful motion. Sleep. Venus glows. Jupiter shines steady.